and how is that what's happening on this side of the table can help you on the other side, and vice versa. So before I go further, I'd like to maybe, you can just put your answers on the chat box here. Uh, I'm sure you already are familiar with what typically large language models are. How do you actually use these large language models for various things? I'm sure you would know the importance of small language model as well, right? Why is it so relevant in the context today that we are talking about small language models, and why we need to actually fine tune our LLMs if we are to make them use for enterprise use cases, right? So if you're familiar with these concepts, please do put a yes. If not, then put the topic as well. I'll try to pick that up on my way. And before I go further, I would also like to try to understand how many of you are actually hands-on with model development, from a typical conventional AI point of view, right? So just let me know so that it helps me structure my thought process as I'm talking to you, right? What should I be covering? I have multiple things open on my machine. So how you would like to steer this conversation will be the way I'll be covering this. Okay. So your answers are really important. Um, okay. No responses on chat. Please feel free to engage, right? So let me get going in the meanwhile. I see. Okay. Now, when we talk about large language models, right, and even before that, we step back a bit and try to understand where did we find challenge with adoption of AI, right? AI had been there for long, right? But then recently we are seeing a lot of adoption of AI in various segments, right? But despite the fact, there are still a lot of areas where we're not able to do that, right? What are those typical challenges that you see, that you understand are the ones which are holding back the adoption of AI? Anybody, if you can put it on chat, it will really help. Why do you think we are not able to adopt to AI, given the promise it has to the extent that we could?
Dr. Mani, I think the reason is like mostly the resources, computational resources, GPU, graphic cost requirement, and the cost of training and all.
Okay, of course, that's one, right? So, but having said that, computing has really come down over the years a lot compared to the time when we were growing up, right? And the kind of hardware cost it was back then compared to what we have now, the basically, the cost of the computing has really, really come down big time, right? Uh, yeah, and so data pre-processing, actually, if we just go back a little, before pre-processing, the availability of a data is a major problem, right? Because AI needs a lot of data. Unless you have a lot of relevant data, that's what fuels AI. If you do not have data, then you can't do anything with AI. And then of course, once you have data, how good is your data? That's where the data pre-processing comes into play, right? Whether the data is good enough to be used for AI, or it has a lot of noises, in terms of, if we can say so, noise to be basically used for model. And that's where the pre-processing is really, really very important. So these are a couple of, and then there are a few more, right? But then, yeah, let's try to begin to build the discussion based upon that. So one, we said data is a bigger problem, right? Imagine you want to do a machine learning, or you want to do a predictive analytics for some data, for some use case in which, um, for some manufacturing process, right? But you do not have data. You need to have enough data to basically establish patterns, train a machine learning model with that data, and then put that model to use before you can start making predictions, right? But if you do not have data, as I said, right? So now, where do you get the data from? One way is you go back to the field and start collecting the data, but then that's only as much you can do, right? Besides, there are a lot of segments where the data is not publicly made available. You talk about healthcare, you talk about so many other places, right? You will not find the stakeholders opening the data for you to basically work on, right? So yeah, that's again a challenge, right? How do you basically get into that data then? So yeah, so we'll cover that piece today, right? How do you really address that problem of data? Okay. Um, so next thing is we talk about uh, computing resources. We already talked about, right? But again, most importantly, for our AI to be working or working in a right manner is whether your AI is explainable. Means is the AI able to explain what it is doing, right? Is it an explainable AI or not? AI can no longer be a black box, right? Whatever actions the AI is inducing or predicting or projecting, they need to be explainable. And that's where the concept of explainable AI comes into play, right? And then we talk about bias, right? Is your AI really bias free, right? Have you really put those guardrails in place so that the AI that you are doing, the implementation that you're doing, is not actually, getting in towards the bias thing, right? So these are a couple of challenges which the conventional AI, for that matter, any AI faces for adoption. What we are going to talk about today will address a few of these points what we just talked about, right? So let's go back and talk about our conversation about uh, large language models that way we see, right? And so you all understand a large language model is like a model trained with all possible kinds of data, right? uh, So to say, let's say, and I'm just hypothetically giving you an example. Let's say there is a large language model which is geography specific. Okay, just assuming, right? So let's say there is a large language model which is trained with absolute any data which is available with respect to the state of Rajasthan, for example. We can pick some domain as well, manufacturing or something else. But the large language model is basically large. So the point is, if that model is trained with the data till 1 month back, let's say the model was trained with all the available data till last month available data. But today that model may not be the relevant data, may not be relevant and updated. Why? Because it isn't trained with the data which has got accumulated in last 1 month, right? So that means we are still working with a model which is not so very current, which is not very up to date, right? Similarly, explainability I talked about, right? Now, let's say a bank is actually using a AI-based model to assess, whether a particular person is a good fit for being given a loan or not, right? Now, that model would have been trained with some data, and then when subjected to the user's data, that will actually churn out some predictions. So conventionally, we have these CIBIL score, but today the banks take a lot more, other inputs into it other than only the CIBIL score, right? So let's say the bank, I go to a bank and I say I want a loan for 10 CR, right? And let's say the bank actually rejects my request for a loan, right? Now, there cannot be a case where the bank cannot tell me why they have refused it, but the bank needs to give me a reason for refusing my loan, right? So if there is a process which is being implemented by some AI based system or something, there has to be a way to make that to be explained to the stakeholder, right? Okay, your loan cannot be sanctioned because of these 1, 2, 3 reasons, right? Your net worth is this much, you're expecting a 10 CR loan, which is so much less percentage of that particular amount. There can be n number of reasons, but then those reasons needs to be explained, right? So and that will really, that's where the taxonomy really helps in terms of how the model is actually getting trained and tuned for that matter, right? So let's go further and try to understand more about this. Um, so we just talked about, right? We see a lot of adoption in the AI based application across the sectors. We see a lot of generative AI adoption, right, from customer services to product design to n number of applications, right? A lot of organizations today are in the process of either completing POCs or already completed POCs. POCs is proof of concepts, right? For particular use cases, like how they would like to implement the case of AI in the to enhance the business processes, right? So typically, if you see if you would be reading the newspapers or the magazines, you'll find a lot of traction around organizations playing with. Earlier, it was traditional AI. Then typically generative AI, and today we talk about agentic AI, if you are familiar with, right? So there is continuous churn in terms of how AI is being used, is being interpreted to use for that matter, right? And hence LLMs and all of that actually form a backbone of all of these kind of implementation that we're talking about, right? Okay. Now, please feel free to put your questions if any, right? Yeah. Okay. Now, what we are talking about here is LLMs typically are trained with all kinds of model, right? So imagine you have basically a room full of hay, right? And then you are supposed to find a needle or maybe let's say some bigger thing in a stack of hay, right? So querying that hay, getting into that hay and retrieving that is still a long, complex, effort-taking process. Number one. Number two, imagine the models, the kind of large language models we have, right? Imagine the kind of training costs would go on in terms of training those models with so huge resources, so much of data, right? And if you again go back to what ma'am just put on chat, right? Data pre-processing. Any data, but whichever has to be used for training a model needs to be pre-processed. If you understand the cycle of the entire, AI machine learning data and all that, you will find 80% of the resources, 80% of the time is actually consumed by data pre-processing itself. So imagine if you're doing this pre-processing with so much of data, how much labor intensive, how much time, how much domain knowledge will that require, right? And of course, yeah, so there has to be, currently there is no such way to basically make people to contribute, but then we can definitely work it out, right? So now let's get into more about the large language models, how foundation models work, and typically like that. So as I was giving you this example of all the there is a LLM, let's say, for example, which is trained with all the possible data only specific to Rajasthan, right? LLM dedicated entirely to the state of Rajasthan. So that data will have what it can have: the culture of Rajasthan, it can have the food of Rajasthan, the geography of Rajasthan, the crops of Rajasthan, the weather of Rajasthan, whatnot, because we're talking about, this can have all kind of data which is publicly available with for the state of Rajasthan, right? And then you basically train your foundation model with that. Now, let's say you have this huge LLM, right? And now there is one of these hospitals in, Rajasthan, in Jaipur, let's say SMS hospital, right? Which basically wants to use this LLM for medical related something. Now imagine that huge information with this, which is what this LLM is trained with, and then you are basically trying to connect it with something which is very niche, right? Of course, there is a lot of medical data also within with the model with which is trained, right? But the point is, how precise would that query actually be when you're trying to query a particular, a model trained with so much of data, and then you're doing a very specific query to that model, right? You typically write prompts for that matter, right? You're writing something on that. So when you actually, again, the point is finding a needle in a hay, and then that may not be very precise. That may not be to the very much to the point, that answer, right? And hence it does not serve your purpose. And that's where the entire conversation about how do we fine tune, how do we, or do we really need to fine tune, actually comes into play, right? So typically there are certain challenges, right? These are a few, right? We talk about how with the existing models, we do a fine tuning with pre-trained models to some enterprise use cases. For example, in this case, we need to fine tune this entire model, which is trained with the data of Rajasthan, to certain data which is needed at the by the medical fraternity, right? So need to fine tune that, right? So that means that domain specific data, particularly again with the geography specific inputs, has to fine tune that bigger LLM, right? And then it can be made to use the way the SMS hospital wants to make use of it, right? Two, there can be a huge computational cost for training and running these models, which may not be possible all the time to do it. And of course, between the process of training the model and deploying the model, there could be a lot of costs, right? So these integration of business data to this actual model that we are trying to use may also entail something called as the PII, personal identifiable information, right? Or data, which is data privacy and security issues while we are sort of doing it for the, trying to fine tune the LLM, right? So all of those are the typical challenges that we can really face. Now, where do we start? How do we actually get into this? So first thing is, there are a lot of LLMs available, right? There are a lot of large language models available for. Now, each model may not be the right fit for the job that you're trying to do with it, right? So you need to find a trusted base model, right? The place that you start from, right? And once you have that, then you basically, work with your own data with that base model. And once you have done that fine tuning, then you deploy and then you scale and do whatever you want to do with that AI piece, right? So if I can actually use this infograph here in this manner, right? Then wherein you have a certain kind of data, you basically pick up the right model, which can actually lower the inferencing cost up to 42 times, right? Now, inferencing cost is the same thing that I was talking to you about, finding a needle in the hay, right? And then you basically, fine tune that right model with the use case, the domain specific data that you want to query the model for, right? So we picked up this Rajasthan LLM. Let's say that's the right model for us. Then we basically fine tune it with the medical data, which is relevant for the people of Rajasthan, for the kind of diseases that happen, in that geography. And then maybe SMS can actually use that model for what they intend to use in their research, or they want to use it for patients, whatever they basically want to use it for, right? So that's how typically we're going to work on it. Now let's get into how do we really choose the right AI foundation model. Now, before I go further into it, let me ask a few questions to you. Now, do you understand how do we find a right algorithm when we actually do a machine learning? There are tens and tens of algorithms available, right? Which one of that is actually the best fit algorithm? How do we actually find that? Any answers? Anybody? See, I would actually request everybody who has joined to basically there is nobody here to judge you. You may be correct, you may not be correct. Doesn't matter, right? It's all about engaging. Um, so I would request you to please, try to be interactive, right? And I keep telling this whenever we ask a question, we basically are doing charity to all the others, right? So if there are like 20 people in this room and one of them is asking a question or putting a query, that person is doing charity to 19 others. Why? Because if or she, he or she wouldn't have asked a question, 19 others wouldn't have heard the answer, right? So it's really important that we talk. Um, okay. Okay, so let me quickly give you a small demo. I am not sure if you are familiar with this, but okay, Harshit, based on what task? Okay, anybody else? Um, Anybody in this room familiar with how AI is basically helping do research? Anybody? Okay.
Hello.
Yeah, ma'am.
Yes, sir.
I just wanted to understand if there is, a background about how we are using AI for doing research or helping in research. Anybody?
Okay.
Hello.
Okay, discovery
Yes, sir.
and
AI is
please
helping us.
go ahead.
AI is helping us in let's say we have a data in our research. We can process it or take out the results from it, classify it. That's that's how we can take help from AI. in our data.
Okay, that's good. What else? So if I can actually give you a view of few AI-based services which are available on IBM Cloud, and I'll not get into the details of this, but then if you see here, right from building conversational interfaces, right, chatbots, right, to developing the entire AI-based solution with the studio, to using, creating those AI pipelines using a Match 360, or using a natural language processing or natural language extract, to extract metadata, understand concepts, entities, and all. Then text to speech, speech to text. Most importantly, what a discovery service, which can basically add a cognitive piece to the search engine. And then, using something called as Watson Orchestrate to streamline workflows, automate workflows. There are a hell lot of services, things available, which can really make a lot of sense from a research point of view for making the life of a researcher easier. I'll quickly give you one small demo. I give this very often to, in a lot of my talks, because it, I believe, is really, really something which helps the researchers big time. So I'm sure most of you, when you start with your research, particularly in an AI ML domain, have one question, right? When you are doing a classification, when you're doing when you're getting started with a machine learning thing, the first thing that you are basically, sort of working with is, there are n kind of models available, right? How do I start my model building, right? Conventionally, it was all using those various approaches, but we have got a lot of approaches to basically build our machine learning models, right? Now, let's say we are doing some, we have a data set and we are looking to work on a data set, right? So as somebody rightly pointed out, the first thing to do is, do the pre-processing for the data, right? So let me just quickly, it's an old demo, but then let me quickly give it to you. I'm creating a project on the cloud, right? And what is it is using right now, do not bother about it if you do not understand, okay? I'm actually looking to build a machine learning model for some data, okay? And this data which I'm using is going to be from banking and finance, okay? And then it is asking me to associate a Watson.ai service. So I have some available services running. I'll associate it with this particular thing. See, it automatically gave me an infra of 8 CPUs and 32 GB RAM, right? I said, okay, create this service for me, instantiate this service for me, okay? And once I do that, it basically will come back to me and asks me, where is the data set that you want to play with? Yeah, please go ahead. Any questions?
No, I could not hear you for like 10 seconds. So now I'm able to hear.
Okay, you're able to view my screen?
Yes, now it is visible, but for 10 seconds I could not hear or see.
Okay, so no problem. What happened was, I basically am looking to create a sample project on IBM Cloud, wherein I am actually trying to work with a data set just to understand how machine learning can really be simplified using AI. Okay. Now, I basically use something called as a Watson Studio and a Watson Machine Learning service on IBM Cloud. This is openly accessible. You can also go ahead and access. And here it is directly asking me, where is the data that you want to play with, right? Where you want to basically work with. So I can actually upload a data set from my, local machine. I can use some other cloud. I can upload data up to 20 GB for this particular kind of application, right? And the moment I upload my data set over here, it basically ingests that data and it is asking me, do you want to create a time series analysis? So I say, no, I do not want to create a time series analysis. Then it asks me, what do you want to predict? Okay. And if you see the drop down here, it basically gives all the fields of my data set there, right? So my data set was about a banking customer, a lot of customers who have taken loan from the bank. Okay, so the bank would have collected information about their gender, whether they're married, dependents, what's the education, whether they're self-employed, all of this. But what I'm interested to know about is whether a particular person will be able to repay the loan that I'm looking to, that the bank has given him. Whether a particular person is a fraud risk or not, that's what I want to predict. So the moment I basically say I want to predict whether a particular person will be able to pay back the loan or not, it says this would be a good fit for a binary classification, right? But I can always go back and I can say, no, I want a multi-class classification, or I want to do this as a regression problem, or whatever, right? And yeah, so let me go back right now and I'll quickly run this experiment, just for the sake of brevity for a while, and I'll come back to explain you what other things I could have done with this. Okay, so I gave the data set to this service, and the service is actually ingesting the data, trying to understand the data. And what it is trying to do is it's basically trying to, create that entire data set, or just training data, the testing data, all that stuff. It's right now trying to do that. Okay, and okay. So it will first read the data set, as I said, then do the splitting. Once it has done, it will basically do the reprocessing and it will do the model selection. Now, it said that binary classification is what it suggests us to do. That would be the best way to do the fraud risk, whether a particular person will be able to repay the loan or not. But then there are tens of classification algorithms, right? There are like 30, 40 algorithms that we can basically use. Which would be the best fit is again the next big question for us, right? So right now the model is configured for picking the best top two algorithms, right? The best top two algorithms based upon accuracy, or you can even set what parameter you would like to, this algorithm to be assessed on: F1, area under RSC curve, accuracy, whatever, that's your call. So right now this is optimizing the algorithm for accuracy, and then it's basically going through that entire process which I was telling you about, right?
So Dr. Mani, this is like can be used for like complex models like NLMs, or like BERT or ROBERT, because that takes a lot of resources. So students can use this for finding out the best model for that kind of data and computation intensive applications. Or there are limitations on using this IBM Watson cloud.
So I'll answer your question in a while, sir.
Yeah. Okay.
Let me first complete, because then I'll be able to actually
Yes.
explain to you, in a better way.
Yeah.
So right now what it did was it basically, identified snap random forest classifier as one of those algorithm which is good in terms of accuracy. Okay, so so what it did was it basically created a pipeline, and then with that it achieved 93.3% accuracy using this algorithm. Okay, but it did not stop there. It went ahead and did a hyperparameter optimization on top of the existing vanilla flavor of snap random, right? But then the accuracy did not change. It is still 93.3% accuracy, right? But it did not stop again there. It went on and it did a feature engineering again on top of that. The accuracy still remained 93.3%, right? And it will again go further and do another round of a hyperparameter optimization just to see whether the accuracy can be further optimized or not, right? So that's one. Then it will go back and select the second algorithm, right? And again, work on it, do the vanilla flavor, and then create multiple pipelines with feature engineering, hyperparameter optimization, and all of that, right? So see this, with snap random, this is the best accuracy that the system is able to derive, which is 93.3%. And it's basically now working on the snap SVM classifier as the second possible algorithm, but then the accuracy there is second highest, which is 92.8%. But this is not what is important. Important point is, out of that bunch of those 30, 40 algorithms, it's been able to pull out the best accuracy algorithm for me in less than 5 minutes, right? Now I can actually use this as a baseline and start to work on this, in terms of uh, whether putting some using some ensembling techniques on top of it, or whatever, in terms of optimizing it for me. But then this is not what is the best part of this. The best part of this is I can actually publish this model as a web service on the cloud, okay, where any researcher can actually use my model and test his data with my model. And if a researcher is doing that, that means they're basically quoting your work to do that, right? So that means from a research point of view, it gives you an entire new dimension where researchers are leveraging the model that you have created, for their data. Okay. But then again, this is even not the best part. This is the best part, right? Whatever the system has actually done in terms of, at the back end, working, creating these pipelines, identifying the best fit algorithm and all that, it actually gives you a fully annotated Jupyter notebook with the entire code base, right? What are the various libraries required? How do you basically create that metadata, right? How do you basically create those pipelines for training data, all of that. You can download this entire Jupyter notebook. See this, you have a download option. You can run it on your local machine. You can basically run it on some other platform, some other hyperscaler, or if I come back to IBM Cloud, use it there. What you can also do is you can actually change the data set with which you are actually doing it, because this is editable, right? You can always edit this. You can add your own piece of code into this. So Vasant sir, I think that I guess that answers your question, right? You can add it to what algorithm is basically being used, and put your own algorithm. If you have already developed, conceived something, you can include that here, make it a hybrid approach, with that. Train the pipeline, okay, again, train the model, right? And then deploy it using, from here. So this entire effort, which you would have otherwise as a researcher done in maybe months, right? Weeks, actually gets, done within no time, right? So that's the power of how people are leveraging AI for multiple things. Any questions about what we just discussed? Oh, okay, I'll go back to you this, and I'll actually explain to you how we can actually.
I have a question as you mentioned, we can update the code and all. And will for example, you have just uploaded the problem data and then selected the problem kind of problem. Then you mentioned it is automatically selecting two algorithms from 30 possible algorithms. But I could not understand how this system is basically selecting two models without checking their accuracy, and that I could understand that two algorithms, they exhaustively checked which of the two algorithms is doing better, or how much they are performing. But I could not understand that how these two algorithms internally has been chosen out of 30 options.
So I'll show you that, sir. Okay. So what we are going to do is we basically are going to add another asset here, and I'm going to repeat it and then maybe name it something. Yeah, maybe I'll keep the same name here. And this time we'll try to customize the experiment. Last time I just wanted to show you the experiment, but this time we are basically looking to understand how it is actually working. Okay, I'll repeat it with the same set of things that I was doing it earlier. And now I'll go to the experiment settings. Okay, now let's try to understand what you were asking here, sir. Now, as I said earlier, right, the system suggested to use a binary classification, but then I can always go back and say, no, I want to solve this problem using some other way. Okay, fair enough.
Yeah.
I can always customize which one do I want to use as a positive class. For me, it's a U0 or a 1. I can also tell which is the metric that I want to optimize the experiment for. So let's say if I don't want to use accuracy, I want to use area under RSC curve, I can use that, or anything else as well, right? And if there is a certain algorithm that I do not want to consider, right, I can always go back and I can say that over here. Because there are all these algorithms are embedded here. Now, this is where the point was I was talking. it will basically pick for top 2 performers. But if I want more flexibility, I'll say, okay,
Okay, I
you
got
need
it.
to tell
So
me.
here is a list of all the
You can
classifiers.
actually tell
Put
me
on.
the top 4 algorithms, which will give me the best result with this data set that I'm looking to play, right?
Okay,
And then
this
if you remember, when I was talking about AI, I talked about AI fairness is the biggest, problem with the AI thing, right? Enabling the fairness, right? So here, by evaluating this, you can actually enabling this, you can actually do a fairness evaluation in the data set for outlier handling and maybe duplicates and all that. You can actually make that all of that available here. Okay.
Yes.
And then there are a lot of other things as well, right? We can check whether our data is sequentially ordered when we are actually, training the data, training the model. I can drop all the duplicate rows. That means all the pre-processing that we are talking about, right? Just by a typical radio button, I can just drop all the duplicate rows in that thing, right? And then if I want to use a kind of a subsampling method, I can always do that, right? With a stratified sampling method there. I can always do a data imputation for the missing values in the way I want to use, right? For example, I may want to use a median or a mean or typical approach. I would like to, do that. What kind of feature engineering do I want to use? Number of vectors per column. So everything, I can actually customize this experiment, right?
Yeah.
I can
So,
say I can.
Dr. Mani, for the deployment, you mentioned it is like we can create a web based like hosting on the So, the models which are based on the large language model, they are very heavy. So this system.
I'm yet to come to that. So this is not about we're basically trying to come to that large language model, that how AI is basically helping us do things which otherwise require a lot of human intervention, right? Once we understand this piece, then we'll basically move towards the same utilization, but from a large language model point of view. Okay.
One question in the chatbot I can read for you is someone has written what if I need to use an algorithm that is not available in the list?
So as I said, you can always download the Jupyter notebook, do a coding for that bit, and you can run it, right? So that's always possible, right?
And
And then
one more
let's say,
question in the chatbot is suppose we have a data set, so is this platform safe to upload our data set regarding the privacy? I think it is safe.
okay, I could answer it directly, but then
Yes,
I would actually put a question to the person that, uh, do you understand about cloud, right?
yeah.
Today, all that you do on your mobile phone, right, from WhatsApp to your Spotify, everything is actually on cloud. So do you really still have that question whether it's safe or not? So, by the way, anything on cloud is an encrypted format, right? Even the upstreaming, downstream of data is actually, encrypted, right? Okay, so let's come back to here. Again, customize. How do I want to split my data in terms of training data versus other? Let's say I want to, I want my data, I want my machine learning model to be vendor agnostic, or sorry, gender agnostic. So what I can do is I can always leave out the gender when I'm actually training my machine learning model, so that whether a person is a male or a female, it doesn't matter, right? Whether he or she would be able to pay the loan or not be able to pay the loan, right? So I can do all those kind of fixes from here. And then I can always, define what kind of iterations do I really want my experiment to use, right? So all of that is actually possible that I can make use of, this particular application from here. Any questions about what we just discussed?
I have a question. You take optimize for accuracy metrics. So that is a training accuracy or test accuracy, like we can test for overfitting and all these things in this.
Okay, so that's basically accuracy in terms of the machine learning model that basically we are training, ma'am. Okay.
Okay.
And by the way,
Next one.
you can
Yes, yes.
you can see me deleting all that I'm doing. Why am I doing it? On the cloud, the best practice is if you're not using a resource, it's always better to either stop it or delete it. Otherwise, what will happen is we are consuming. It's like, you hired an auto and you've kept a meter running, and you're reached back your home, or you'll come to a lab to do something, but then the auto is waiting for you and the meter is running, right? So since I do not want to keep the meter running. So I basically deleted that service which I was actually talking about. Please continue. Sorry, I think you were saying something.
Next question is if I want to provide a data in this, then there is a special form like if I have image data and image and labels are there, then it is necessary to provide 0 and 1 for label folders, or it can take in any form.
Sorry, I'm not able to understand, ma'am. Can you please repeat?
Yes. If I have any images data, image and labels are there, and there is a folders in a directory. So there are name of disease and normal images are there. So it is necessary to convert in 0 and 1, like in numeric vision.
No, it's not necessary to do that, ma'am. Yeah, the system will work on it.
If
No,
any
no,
type
no,
of
no,
data
no.
I will provide, it will process it.
Yeah, but it needs to be, then the machine learning model that you want to train with that data needs to be the right one, right?
Yeah. Okay. And this is for unsupervised and supervised for both.
Yes, ma'am.
Oh,
Okay, so let's go further, right? And let's go back to the conversation which drove us here. Okay. So we were basically trying to talk about choosing the right foundation model, right model for that matter, right? Now, I'm sure you all would be familiar with this piece of information, right? There are various kind of foundation models already available there, right? You'll find a Llama, you'll find a Granite, you'll find Mistral, you'll find Granite, you'll find a lot of them there, right? There are so many more, right? I'll say a few all, right? Yeah, see this? I'm scrolling down. You'll find Llama there. You'll find where is that gone? You'll find Mistral there. You'll find Alam there. You'll find Flan there, right? A lot of them there. Now, do you understand what these large language models actually stand for? How are they? Do you understand this piece before I go further? Anybody?
Yes, we understand.
Oh, great. So if that is the case, I would have another question is, do you know how a Flan or a Mistral or some other model can be differentiated against a granite-based model, a granite model?
No, so that is not like we don't know that.
Okay, so so a Llama or a granite or all that, how do they actually differentiate with granite? I'll give you a small example, and again, I keep giving this example in almost all my talks. So I'm sure most of you would have actually traveled on, the state roadways buses, right? Or you would have actually gone to those roadside eateries that we, often go, right? Now, let's say, you want to buy a bottle of water, for example, right? Now, how much does a water bottle cost when we are traveling and we have to buy it offhand?
20 to
Anyone?
30 rupees.
30 rupees. Okay, what else? Anybody else? I'm sure all of us travel, right? And we often buy water bottles as well. So I'm simply asking is how much does a water bottle that you buy costs you?
So depending upon like from where we are buying, maybe on airport it is like too much costly, and that's it, maybe less.
Acha, okay. So, okay, fair enough. Let me elaborate my example. Maybe that might give you more what I'm asking for. So let's say I'm traveling on a Rajasthan Roadways bus from maybe Jaipur to Tonk or Jaipur to Kota, someplace, right? And then, on the way, the bus stops at certain railway crossing or some place where few people will actually, some kids will come to the bus and they will start selling some water bottle, right? You might have encountered that. So when they actually come and they sell you a water bottle, they sell you that bottle typically normally at 10 rupees, right? if you actually buy a water bottle from some joint on the roadside, like a Aquafina or Bisleri and all, they will typically sell it to you for some 20 rupees, 30 rupees maybe. If they say they want to charge extra. Then there is another category of water bottles, typically, which is like Vedika and all, right? Which typically comes in a range of 50, 80 rupees, something like that, right? And then there is some more kind of water, typically, kind of you might be knowing what sportsman Virat Kohli, uh, consumes. I've heard it. It's again a very costly water, right? So do you know what's the difference between all these 10, 20, 40, 80, or maybe 1,000 rupees water? Anybody? They're all water, by the way, right?
Brand. I think it's the
They're all
brand.
brand, huh? Okay. Anything else that comes to your mind? Is it just the brand?
Your water and quality of place.
Okay, quality of water. I completely agree. So what is so special about that 10 rupees for a water bottle versus, let's say, to be on a normal side, let's say on a 50 rupees for a water bottle? What's the difference? Okay, water maybe may not be knowing, but then let's get into the other piece of this conversation. I understand you're all from engineering background, so you would use a UPS in typically in your houses, right? And you might be using you might be seeing UPS in your computer labs in the colleges as well. Do you know the difference between the two? Anyone? We often buy UPS for various things, various electrical appliances at our home, even desktop if we have one. And I'm sure you might have seen a lot of UPS in your college labs as well, right? Can you figure the difference between the two? Do you know the difference between the two? No? Okay, I'll just give this term and maybe you can look for it, right? So typically when we talk about UPS, we talk about offline versus online UPS. So typically the UPS that you buy for your own self at your home for 1, 2, 3K is nothing but offline UPS compared to the UPS which are installed in your labs or studios, where the appliances are very sensitive towards the electricity. Electronic gadgets are sensitive. That's where we use online UPS, right? And there is a stark difference between the quality and the cost of the two. So you would get to know, right? Offline UPS versus online UPS. Okay, so this entire conversation actually came in like Llama versus Granite, or some other large language model versus Granite. Um, so does anybody know the difference between offline versus online UPS?
I think probably the online UPS that can be monitored, like if there is any problem or something in offline and it is not possible. I'm not sure.
Okay, no problem. Okay, see, alternating current, right? AC is typically formed of three components, right? Frequency, phase, and amplitude, right? And it's because of the phase, because of which the nature is of alternating, uh, current. That's what AC is all about, right? Now, because of this alternating value, the phase in the power, right? This particular kind of current is susceptible to spikes creeping in this, right? Okay. And we all know the gadgets sometimes are very sensitive to these electrical surges, right? Whenever there is a spike, right, that may actually hurt, damage the electrical gadget, right? So offline UPS typically is entirely where the incoming electricity, the AC voltage, is used both for charging of the battery as well as giving it to the device. Okay, that's how it works. Whenever there is the AC got cut, the voltage, the power goes away, the device actually is shifted onto the battery, right? But in the online, UPS, what happens is the incoming AC basically is used when it is incoming. It basically gets converted. The AC gets converted into DC. Why DC? Because if you see DC, it's a square wave. So that means the entire spikes or the spiky nature of the current is actually sort of taken care of. With that voltage, it basically charges the battery, of course, there, and then subsequently it actually converts into a AC before being fed into the device. So what happens here is the device is actually fed up pure AC. Pure AC means there is no spikes or there is no probability of a spike in that AC, which is fed into the device. Pure, ultra pure AC. And hence the electronic gadget, you can be ensured that it will not get damaged because of the spiky nature of the AC current. Similarly, when you are actually training a machine learning model with all possible kinds of data available in the globe, right? What I mean to say is, let's say Llama, right? It's a pre-trained model with 13 billion parameters. Llama, right? 70B. It's a pre-trained model with a 70 billion parameters, right? So try to understand the kind of parameters, the kind of data this model is trained with. Now, this data is all and every kind of possible data with what this model is trained with. Compared to this category, the Granite series of models is typically trained with enterprise grade data. Please mind the term enterprise grade data. What does that mean? Enterprise means organizations, companies. So any data which is being used in any organization or being generated by the organization will always be a clean data, relevant data. When you're actually training a model, a large language model with that kind of data, then the model will always be trained with absolute, precise, clean data compared to what other models would be. Number one. Number two, how will it help? Whenever you query this kind of model, it will actually give you more precise answer with less amount of time compared to other category of models, right? And that's what we want, right, as a user, isn't it? So that's basically the difference of what X model versus Y model actually behaves. So if I can give you a quick example how this varies is, let me give you an infograph before I go further. Okay, where is it? Okay, yeah, here it is. So see this, compared to a typical any other model versus a Granite series of model, you can see how, the particular model utilization is actually more cheaper and more precise compared to other category of model. So when you actually compare a Llama with the Granite, right, where we are talking about a 70 billion versus a 7 billion, even with the 7 billion parameter, it is 76% cheaper. Same goes with, a Llama, which is basically, 405 billion versus 7 billion. With Granite, it is again 96.4% cheaper, right? And same goes with other models, right? So you can actually see that. Now, we'll come on to the lab part in a while, okay? But what the point I'm trying to make here is how the choice, remember the question initially, how the choice of base model is really important. Now you get to understand that initial question that I had actually in my mind when I was talking to you, the initial choice of model. Okay, let me go back. Right? So the right model can actually lower up to 42 times the inferencing cost. That's what was the point I was trying to actually make for you. Is this clear?
Yes, sir. Yes.
Audible? Okay. Yeah. So, you need to understand which model actually would be a good fit before you actually get into the process and start doing things, that we are basically trying to talk about. Okay. So let me go back here and I'll sort of go and see how do we choose the. Now that we have discussed it, I'll just skip all of these pieces here. I'll go to the next piece here. Okay, let's go here now. Okay, so the base model that you are going to use, you should be knowing what the contents of that base model are. Why? Because when you add your domain specific data to that base model, to that large language model, what you're doing is you're basically mixing your domain specific data. We said the medical data in case of SMS example, right? With the LLM, which is tuned with the entire data for Rajasthan, right? So you need to know when this combination will happen, how what would be the effect for the enterprise which is consuming, what will be the effect for SMS when they're consuming that model, right? So that's why it's really important that how do you actually start that. And of course, you need to start from a trusted base model and then customize either the model with the data representation, right? Okay, we'll skip this. You're all familiar with this, right? Let's come to the fine tuning piece, right? Okay. I'm not sure if you are familiar with something called as a lab approach, but that's what I'm going to talk about like this, right? So there is a offering called Instruct Lab, which is a open source approach, right? For basically, which uses something called as a lab, large scale alignment for chatbots. That's the approach, which is taxonomy driven, which uses large scale data generation. And it's an iterative model for tuning, alignment and tuning of a large language model. Okay. Now, let's try to understand this. How does this typically work, right? Now, a large scale alignment lab model, what it does is it typically generates very high quality. Okay, before we understand this, let's try to understand something more. Are you familiar with? So if you remember towards the start of the conversation, I was talking about data is one of the biggest problem or one of the biggest constraints or barriers to basically, adoption of AI the way we talked about, right? And we also mentioned that for something there may be data available, but then there may be certain use cases where the data may not be available, right? Now, in case there is a use case for which there is not enough data, how do you think we can solve and we can make a AI model for that? Any idea, any questions, any answers, please? Anyone?
They are saying augmentation in the chat.
Okay. Okay. Let me try to make the answer or question even more clearer. How many of you actually like jokes? I'm sure everybody likes jokes, right? Yes or no?
Yes.
So let's say, we used to like Chacha Chaudhary jokes a lot, right? Or Pinky, there used to be a comic character called Pinky, right? And it used to be comic strip with a lot of things around. So we used to like the jokes around that, which no longer are available or they don't come anymore, right? If we are to get more jokes of that kind, okay, the easiest way to do that is we basically use some available jokes of Chacha Chaudhary, let's say 10, 20, 50 available jokes of Chacha Chaudhary. Okay, give it to a teacher model. Okay, the teacher model basically creates hundreds and thousands of Chacha Chaudhary jokes based upon the taxonomy of the model. And then there is a critic model, okay, which basically checks for the worthiness or the laughability of a joke, whether a joke is really funny or not. A joke, if it is not funny enough, we take that joke away off from that. If it is good enough, we retain it there, right? And then we basically train the large language model with those kind of jokes. So typically a teacher critic model is something which is very key to something called a synthetic data generation, which is what we use in this kind of approach. Why do we use it? Because we said there may not be instances where the enough data is available for training or fine-tuning a large language model. So for that approach, we basically find some curated knowledge resources. We do a curation of taxonomy of whatever tasks, right? Whether it is a knowledge thing or whether it's a skill-based thing, and then we create a taxonomy for that. Based upon that, we basically give it to a teacher model, which generates, based upon that taxonomy, it will create millions and millions of those, outcomes. And then we do the validation of the outcome with a critic model. What for? For checking the correctness and the quality of the, thing. And then based upon this validation, we train or fine tune the student model. This is typically the approach or the method which InstructLab follows for fine tuning the large language model. Any questions so far? By the way, this is an open source project. Okay, you can always go on github.com/InstructLab. You'll be able to find that and able to even contribute to it. So this is where I was actually coming to try to understand, explain to you, how is it making the model better? How is it really helping the large language model perform better? See, for the gray one, for a granite 13 billion, once you basically use a lab approach, you are able to enhance the performance almost double. See that? And same goes for all other models, right? You are able to enhance the model's performance using this lab approach. What was the lab approach? Typically, we basically said large scale alignment for chatbot. That's typically the lab approach for enhancing or fine tuning the large language models. And you can see the outcome over here. How is the performance? How is the performance changing? Okay. So I'll take a pause here before I go further, right? Any questions so far? Any questions so far? People you are using it all the time, right? You can see, people using AI generated images for all kinds of things, isn't it?
Yeah.
There is a question in chatbot. Can we use synthetic data generation for images?
Yes, of course. That's what I was answering, ma'am. We every now and then see, right, AI generated images. Okay, so there is, yeah. Okay, so any other question towards this? Say this. So we are basically having a synthetic data generation and doing a base knowledge, the base large language model, foundation model. We basically do a alignment based upon this synthetic data. And then when we evaluate and we integrate into the model that we are going to use, right? Typically, this is the workflow here. Okay. Any more questions about what we just talked? Let me go back to this then, if not. Now, this is again a platform where you can use all of these, agents, prompts, a lot of these things, right? So I'll quickly go here. Okay, and let me use something here. No, I'll basically create a new one. So what I'm doing is I'm again creating a blank project, guys. Please do not worry about, what am I doing here? Okay. Now see this, I've just created a sample, application for any kind of a chat thing, right? And okay, so typically, this is what it will keep giving me. But this is not important. This is something you can always do. It's basically using see this llama, which is with 70 billion to be, which is used, as a foundation model to power this chat. What I can always do is, which is the most fascinating, beautiful thing is, I can add my own document. So let's say you are preparing for a AICTE inspection or maybe a UGC inspection, right? And there are a lot of compliances, a lot of things that you have to do. What you can always do is upload those documents and of course images as well if you are working on that. But this is important. You remember that somebody asked, can we generate images, right? So you can add your own master or that teacher images, right? And then based upon those teacher images, you can see a lot of those student, critic images, which can be then, used in the student model of yours, right? So I can always go ahead and upload documents of mine that I basically want to work with or query with. And based upon that, I can query those models after I upload those documents over here. So my output, my query, my prompt response will be a lot more precise, lot more to the point when I use this approach. Do you understand my point of view, guys? Okay, I'm not sure if you are, but yeah. And at the same time, if you see importantly this particular piece here, right? As I said, for AI, it's really important that AI has to be explainable, bias-free, right? That's what all the guardrails for. So you can always go back and you can actually enable the guardrails and you can, what kind of, whether you want to use a PII, whether you want to disable it, you can actually configure all those as AI guardrails right from here, right? Okay. Any more questions for me?
No questions, sir.
No? See, we can keep on talking, but then unless, there are more questions, it will not make any this thing. So if not, then I think we are good. Let's stop here. And if there are any questions, feel free to reach out to me. I'll be more than happy to answer now, later.
One question which is coming to my mind is like in the starting of the session, you sorry, you mentioned about one problem, real world problem, like when we train a very heavy large language model with given data. And let's say after 1 month, new data comes in and our model which we have developed is now like obsolete. So how we can take care of this kind of problem, or how industry take care of this kind of problem where data is incrementally come into the system, but we have to stop somewhere and then train the model and then we have to use it. Like,
Sir, one, the data will not get obsolete. It will actually, there will be an increment to what the
yes,
last
yes,
data
yes, yes.
will be
That's what I
trained
mean.
on.
Yeah.
Right?
So,
So, see, with large language model, the problem was all about the use of compute, heavy intensive compute time required for retraining the model, isn't it? What if you are only fine tuning the model with that incremental data that you have received in the last 1 month, which
mm,
is hardly any effort, right? So you keep retraining or retuning the model with that incremental data, and hence the model always remains updated with the contemporary information that is available to you.
okay. So, like iteratively after a week or so, so that
Yeah,
can discipline that.
that can, you can set up the process where after 1 month you want to do it, after 6 months you want to do it, right? When it makes more sense, what kind of business this model is treating. For example, if it is a medical related, thing, then the research typically in any 6 months you can accumulate all the updated research in that area and update the model, right?
Yeah.
But then banking processes normally don't change for years altogether, right? So you may not be needing to retune or rechange the model.
Earlier in ChatGPT also, it was like we can to see that the data, the answers are like based on the database, and information in the ChatGPT is up to this date. Now they don't see show as such kind of a message.
Mhm. Right, sir.
So anyway, I think, Madam, if we do not have any questions from the audience, so I think
Yes.
we can conclude the session. Dr. Mani, I'm very thankful for accepting our invitation and giving this great, insightful lecture. And it is very helpful, I'm sure, for everyone. Madam, please.
Yes, Dr. Mani, we would like to extend our heartfelt thanks